So graphs of trigonometric functions. I've shown sine x all the way from negative 2 pi to 4 pi, or negative 360 up to 720, because I want to point out a couple of things. So the amplitude is really important. The mean line is the line that goes down the middle of the wave. It won't always be the axis when you transform it, but we can see that's the mean line there. The amplitude is the distance from the mean line to a maximum or a minimum. In this case, for the sine, we can see that the amplitude is 1. It's the same for the cosine. The period is the length of a complete wave. So on here, there's a complete wave, and then we can see it repeats itself. And that's at 2 pi. So the period is 2 pi for the standard sine, or 360 degrees. So we've done that here. Amplitude is 1, period is 2 pi. And now you're going to go onto the worksheet and you're actually going to investigate, I think, the cosine. And you'll see it's very, very similar to the sine. Have a good look at the sine here before you go and have a look at the cosine, and you'll see how closely related they are. So we're going to continue on. And the graph of the tangent function is much more complex. Okay, so I actually want to look at that graph. And we know the definitions of the sine, cos, and tan. It should be fairly obvious from there, but I'll just work through it. So tan x is, we're saying it's sine x over cos x. So tan x is opposite over hypotenuse over adjacent over hypotenuse. And again, dividing fractions, so opposite over hypotenuse multiplied by hypotenuse over adjacent. Cancel those. And what have we got? Opposite over adjacent. So tan x is sine x over cos x. And the point is that every time the cosine is 0, therefore, we're going to be dividing by 0, which we're not allowed to do. So we get these asymptotes, these vertical asymptotes at pi by 2, 90 degrees, and at 3 pi by 2, 270 degrees. Those are points where the cosine is negative. So it goes off to infinity there. When the sine is 0, obviously we get zeros. So the tangent looks like this. Now, it's not a wave at all. It doesn't have any sort of meaningful amplitude. I've got that noted here. The amplitude has no meaning. The period is pi radians. If we look at a complete one, it's that, and then you can see it just repeats from there on, and that's at pi. So the period for the tan is pi radians.